also face some problem range, some components. So let's take a look at something like that. So in this one, this is an old AP question. You see we have some device that we'll label D, and that needs to have a voltage across it of 12 volts amps in order to work correctly. And they give us two different circuits to put this in and make it work. So first off, we've got a constant of 24 volts for this one. So in order to make this one work, which this component which has to have 12 volts going across it, we can see that we have to have some voltage drop either before or after our device D. I'll go ahead and put in D here, and we have to have some kind of a resistor beforehand. So we have to have a voltage drop here that has to be 12 volts there, because this one has to be 12 volts also, so this has to be a total of 24 volts. Alright, and let's see, with a with that resistor in there giving a 12 volt a 12 volt drop, this one giving a 12 volt drop also. Be happy, so we just need to figure out, okay, well, how big of a resistor would we need to put in there? How many ohms worth of resistance would that be? Well, in order to figure that out, we need to know how much resistance our device D has. Well, since it has 12 volts across it and 2 amps across it for proper operation, V equals IR. So R is equal to V over I, 12 volts, over 2 amps, which is 6 ohms. So this has to be also 6 ohms for the resistance. And so if we've got 6 ohms there, and that's 12 volts, you can see that this would be 6 ohms as well. But if you're not quite seeing that yet, that's okay. We know that we have to have a current here of 2 amps, which means the current all the way through here, since there's just a single path, has to be 2 amps. So this resistor has 2 amps of current going through it and 12 volts, and so it has exactly the same calculation. 12 volts over 2 amps gives us 6 ohms. It actually asks us to do this just with 3 ohm resistors, so let's get rid of what we wrote down here. Instead of that, keep it neat and tidy for our responses to the AP things. We need to have a 3 ohm and another 3 ohm there. There we go, that'll do the trick. In the second question, it asks us to do the same thing, but this time we have a set current coming into a certain area instead of a set voltage coming into a certain area. So we know that we have to have 2 ohms going through our device D, 2 amps going through it. We've got 6 amps coming in here, so we've got to sped up into at least 2 spaces before it goes to D. So we want just 2 amps going this way. And then we need some kind of a resistor here with 4 amps going through it. Okay, and then D, we said, had a resistance of, 6 ohms. So that means that the voltage across D here is has to be that 6 ohms again, times 2 amps. So it's 12 volts. That's the same value that we found up here, 12 volts. So that means that there must be 12 volts here as well. So 12 volts and 4 amps. So V equals IR. We've got 12 volts equals 4 amps times the resistance. And so our resistance is just going to be 3 ohms. So it says just do this with 3 ohm resistors. So we can do that very easily with 3 ohm resistors. Let's just put in a single 3 ohm resistor there. So D here, and then in parallel with that, a single 3 ohm resistor.